we are going to be looking at beta and gamma function. We want to destroy beta and gamma function. And when we have spoiled it, we will now make a show of it openly. We want to make a shame of beta and gamma function openly. Now, I'll start with the gamma function. Let S be in R, that is, let S come from the set of real numbers. The gamma of S is denoted by, this is how we denote gamma function. This is gamma symbol. So gamma of S is given as this function. Gamma of S is equal to integral from 0 to infinity of e raised to power minus t raised to power s minus 1 dt. So the value we obtain from this is what will be the value of the gamma function. So, or we say gamma of s plus 1. Look at it. What happens is that s, when you have gamma of s, you have s minus 1 here. It's always constant for you to have e raised to power minus t raised to power, what is here, minus 1, s minus 1 dt. These three are the dummy variable of the integral, for the integral. So, or you say gamma of s plus 1. Gamma of s plus 1 will be equal to integral from 0 to infinity of e raised to power minus t. Now, this is s plus 1. You can say I have t raised to power s here. When it is s, I have s minus 1. So, in reality, what is inside this bracket will be what will be the power of the t. Then you subtract 1. So, this one is s plus 1 minus 1. Plus 1 minus 1 will give 0. So, that's why we are left with t raised to power s dt, where s is greater than minus 1. So that is the definition of the gamma function. Now there are some propositions you need to know. Proposition 1. So in reality we are in the first item of the beta and gamma function. This is the first thing we are looking at in beta and gamma function. Proposition 1. Number 1 is saying that gamma of s plus 1 is equal to s gamma of s, which will now still be equal to s minus 1, s minus 2, till I get to gamma of s minus n. And the second one is gamma of n plus 1 will be equal to n minus 1, n minus 2 till I get to 1, gamma of 1, which will eventually become n factorial. So, with what we have gotten, we will now need to show that gamma of 6 is 5 factorial. This is the first thing we need to show. This is the first thing we want to show. Now, these are properties of the gamma function. Now, we want to prove all these things. So, this is what we are going to do. To prove A, we have gamma of s plus 1. What is gamma of s plus 1? By definition, gamma of s plus 1 is equal to integral from 0 to infinity of e raised to the power of minus t raised to the power s dt. So this is an integral. I will now use differentiation by parts. Integration by parts rather. Integration by parts. I will let you to be equal to t raised to the power s, and then dv to be equal to e raised to the power minus t dt. Differentiate with respect to t. Du will be equal to s t raised to the power s minus 1 dt. So if I differentiate with respect to t, du will be equal to s t raised to the power s minus 1 dt. Then this one, I will integrate this one. If we integrate this to get v, we have minus e raised to the power minus t. So that gamma of s plus 1. In case you have forgotten integration by parts, integration by parts just says that when you have integral of u dv, it will be equal to uv minus the integral of v du. So that's what I'm using here. So this will be equal to uv. So this is u and v minus t raised to power s e raised to power minus t. Don't forget the value from 0 to infinity minus integral of v du. Integral of v, that is minus e raised to power minus t, multiplied by du. Du is s t s minus 1 dt. So that's what I have. So that gamma of s plus 1, gamma of s plus 1 will be equal to, when you put infinity here, this one converges faster than this. E raised to power negative infinity is 0. And when you put 0 here, this one will make it 0 as well. So this whole thing will become 0. When you put infinity, e raised to power negative infinity is 0. And by the time you put 0, this will be 0 raised to power s, e raised to power 0, which is still give me 0. So by the time you put these boundaries, everything becomes 0. So now, minus times minus will be plus. Since I'm integrating with respect to dt, s is a constant, so it can come outside the integral. Minus times minus plus, s can come outside the integral of s, integral from 0 to infinity of t e raised to power minus t, ts minus 1 dt. Observe, e raised to power minus t and t raised to power s minus 1 dt is gamma of x. So that I will have gamma of x plus 1 will be equal to s gamma of s. So that's it. This is the s. Then the gamma of s is all these ones. Gamma of s is all these ones. Don't forget the definition. Gamma of s, if you check this and you check this one as well, you will see that they are actually same. They are the same thing. So I prove this to become this. So now, if you continue, I've done this. It's now remain for me to show this one here. So I have gamma of s plus 1 to become s gamma of s. So what does that mean? It means that when you have gamma of s plus 1 here, is equal to s gamma of s. That is, what is inside here? What is inside here? S plus 1. Subtract 1, that is minus 1. You will have both. The answer will be s. So that means gamma of s plus 1 will be equal to, when you subtract 1 from what is inside, you will have s, gamma of that same thing. Gamma of s. So what am I trying to say? What I'm trying to do is that it follows that if you have gamma of s, subtract 1, it will still be s minus 1, gamma of s minus 1, as you have shown here. We have proved it already, so it is true. Gamma of s will be equal to s minus 1, gamma of s minus 1. What about gamma of s minus 1? Gamma of s minus 1 will be equal to s minus 2, gamma of s minus 2 as well. And that is how it will continue to go till you get to gamma of s minus, say, n. This one will be, let me use s minus n plus 1. This one will become gamma of s minus n instead. This one will become s minus n, gamma of s minus n. That's what we are going to have, and it goes on like that. So the implication is that gamma of x plus 1, gamma of s plus 1, which is equal to s gamma of s, will be equal to s. Gamma of x is s minus 1, gamma of s minus 1. So only this one, gamma of s is s minus 1, gamma of s minus 1. Gamma of x minus 1 is s minus 2. Gamma of s minus 2, that would be s minus 2. Gamma of s minus, and gamma of s minus 2 will be s minus 3. Gamma of s minus 3. It goes on till you get to this place. So it goes on like that till you get to s minus n, gamma, till you get to, it goes on like that. Let me write it below. S minus n gamma of s minus n. We are through with the first one. That's how it is. The second one, B, gamma of n plus 1. Obviously n plus 1 is equal to n minus 1, n minus 2, till you get to 1, gamma of 1. Of course, this one, the case is where n belongs to n, where n is a natural number. That is when n is a natural number. It's a positive integer. So this one will be true, that is, this gamma of n plus 1 will actually be equal to n factorial. So just replace, we have proved this. Replace x with n from 1 or from a. It follows that from a, put s to be 1. I have gamma of n plus 1 is equal to n gamma of n. Gamma of n will be n minus 1, gamma of n minus 1. Gamma of n minus 1 will be n minus 2, gamma of n minus 2, n minus 2, gamma of n minus 2. Gamma of n minus 3 is n minus 3, gamma of n minus 3. So n minus 3, gamma of n minus 3, and it goes on like that. It goes on like that. You get to n minus n plus 1. You get to n minus n plus 1. So that will give you 1. You get to 1 actually, gamma of 1. So we don't know what gamma of 1 is. Let's find what gamma of 1 is. Gamma of 1 will be equal to what? Using by definition, gamma of 1 is equal to integral from 0 to infinity of e raised to power minus t raised to power 0, because that will be t raised to power 1 minus 1 dt. So this one will be equal to integral from 0 to infinity of e raised to power minus t. Anything raised to power 0 is 1, so e raised to power minus t dt. If you integrate this, you are going to have minus e raised to power minus t from 0 to infinity. By the time if you put infinity there, you have negative e raised to power negative infinity. That will give us 0. E raised to power minus infinity gives 0. So that will be 0 plus, it's supposed to be minus, but minus times minus makes it plus. Anything raised to the power of 0 gives 1. So 0 plus 1, that will give me 1. And that will be the answer. So that's the answer. So gamma of 1 is 1. So at the end of the day, we are going to have so that at the end of the day, we are going to have gamma of n plus 1 to be n minus 1, n minus 2, till I get to 1, and that's exactly n factorial. Gamma of n plus 1 is n factorial. So to do 6 is very simple. Gamma of 6, that means put n to be 5. 5 plus 1 is 6. So gamma of 6 is equal to 5 factorial from B. And what is 5 factorial? 120. That's the answer. So we are moving to another example. These are the first one. Now, examples. We have use or using gamma function. Using gamma function. Evaluate. Using gamma function. Evaluate. Number 1. Integral from 0 to infinity of s raised to power 6 e raised to power minus 2x ds. Number 2, integral from 0 to infinity e raised to power minus s cubed ds. The third one, integral from 0 to infinity y squared e raised to power minus 2y raised to power 3 dy. Number 4, integral from 0 to 1 of s mean s raised to power 3 ds. Then lastly, number 5, integral from 0 to 1 of s raised to power 4, open a bracket, log of 1 over s raised to power 3 ds. This is what we want to solve. This is what we want to solve. So the first thing we do here, we want to do number 1. Number 1, integrate from 0 to infinity of s raised to power 6 e raised to power minus 2s ds. We want to solve this. This is what will happen. This is what is going to happen. Recall gamma function. We want to use gamma function to evaluate all this. What is gamma function? Gamma function is from 0 to infinity of e raised to power minus t raised to power of s minus 1, that is for gamma of s, dt. So, but assuming this one is e raised to power minus s, this would have been exactly gamma of 6, or gamma of 6 plus 1. This would have exactly been gamma of 6 plus 1, but it has raised to power minus 2s. So you make it in the form of a gamma function. You will let t to be equal to this 2s. You will let t to be equal to that 2s. At the end of the day, you will see that f will be t over 2, and substitute the s equal 1 over 2 dt. The s is equal to 1 over 2 dt. So when s is 0, t is also 0. When s is infinity, t will also be infinity. So let me write the question again. I have gamma of 0 to infinity of s raised to power 6 e raised to power minus 2s ds. Now I'm now changing the variable. That is, I want to make s, I want to put t. So this is integral from 0 to infinity. S is t over 2, that is t over 2 raised to power 6 e raised to power minus 2s is equal to t. This is 2s, is t. E raised to power minus t ds. ds is 1 over 2 dt multiplied by 1 over 2 dt. This will be, this one will be t raised to power 6, 2 raised to power 6 multiplied by 1, 2 at here. Bring the constant out, that will be 1 over 2 raised to power 7 from 0 to infinity of t raised to power 6 e raised to power minus t dt. So this is what has happened. These two, this is t raised to power 6, 2 raised to power 6. So I have 1 over 2 raised to power 6, that is a constant. Multiplied by another 1 over 2, that is 1 over 2 raised to power 7. So I will now be left with t raised to power 6 e raised to power minus t dt. So this one is 1 over 2 raised to power 7 integral from, this one is exactly gamma of 6 plus 1. Don't forget the definition of gamma function, it is very important. This is 7 minus 1. So that means this is all gamma of x plus 1. Gamma of x plus 1 is equal to, don't forget, you have to remember this. This is e raised to power minus t raised to power s dt. So this is t raised to power 6. That means it is gamma of 6 plus 1 e raised to power minus t dt. Every other thing are the same. So that is why I said this is gamma of 6 plus 1. So this one is 1 over 2 raised to power 7. 2 raised to the power 6 is 64. 2 raised to the power 7 is 128. Multiplied by, this is gamma of 7. Let me put it this way, 1 over 2 raised to the power 7 multiplied by gamma of 7. So gamma of 7 from here is 6 factorial. Don't forget, gamma of n plus 1 is equal to n factorial. So gamma of 7 is 6 factorial. So I have 6 factorial here. 6 factorial is 720. 720 over 128. Then we can cut 4 in 72. 4 in 72. 4 in 72 is 4 in 7 is 1. Remainder 3, 8, 180. 4 in 720 is 180. And 4 here is 32. 4 here is 32. 4 can go again. 4 here, 4, 16. 4 in 18, 4, 16. And then in 25, 4 here, 8. So I think the answer is 45 over 8. So the second question, number 2. Number 2 is saying that we should integrate from 0 to infinity of e raised to power minus s raised to power 3 dx. That is the second question we want to solve or we want to obtain. Well, in this case, the first thing to do here is number 2, let u or t, whichever one you want to use, be equal to s raised to power 3. Why did I make it to be s raised to power 3? I just want something like this, e raised to power minus t or e raised to power minus u. Let me use t so that it will, in case I'm adding too many variables. So let t be equal to s raised to power 3. At least let it be of this form, right? So x will eventually become t raised to power 1 over 3. Differentiate, the x is equal to 1 over 3 t raised to power minus 2 over 3 dt. That's what we are going to have. When x is 0, t is 0. When x is infinity, t is also infinity. So this one will now become 0 to infinity, e raised to power minus s cube. S cube is t. I'm writing the question. E raised to power minus s cube. S cube is t. ds is 1 over 3, t raised to power minus 2 over 3 dt. 1 over 3 can come out as a constant, 1 over 3. Integral from 0 to infinity, t raised to power minus 2 over 3, e raised to power minus t dt. So we are through. This is already gamma function. Don't forget gamma function. Maybe I need to write it out so that you can see that gamma of s plus 1 is equal to integral from 0 to infinity, e raised to power minus t raised to power s dt. So this is e raised to power minus t. And this is the t raised to power s. S is minus 2 over 3. So that means this is exactly 1 over 3 gamma of minus 2 over 3 plus 1 from the definition of gamma function. So this will become 1 over 3 gamma of minus 2 over 3 plus 1 will give me 1 over 3. So the answer is 1 over 3 gamma of 1 over 3. We leave the answer like that because I have not told you what gamma of 1 over 3 is and some other things, or a gamma of a fraction or a number that is not a positive integer. So this is the answer. Number 3, integral from 0 to infinity of y squared e raised to power minus 2y cubed dy. Again, we let t to be e raised to power minus 2y cubed dy. We let it to be equal. we let it to be the power 2y cubed. Why? Because we want e raised power minus t. We let it to be equal to 2y cubed. If we make y the subject of formula, by the time we make y the subject of formula, y will be equal to what? 2 over 3 over 2 t over 2 raised to power 1 over 3. So this is what I have. So dy will be equal to, this one is the same thing as 1 over 2 raised to power 1 over 3 t raised to power 1 over 3. Anything after the bracket is for everything inside the bracket. So actually, I let t to be equal to minus 2y cubed. Then make y the subject. Y will be equal to t over 2 all raised to power 1 over 3, which is exactly same as 1 over 2 raised to power 1 over 3 t raised to power 1 over 3. So now differentiate. The y will be equal to 1 over 3 multiplied by, this one is still the same as 2 raised to power minus 1 over 3 multiplied by t raised to power minus 2 over 3 dt. It's not a difficult something. The y is 2 raised to power minus 1 over 3, everything over 3, t raised to power minus 2 over 3 dt. That's what we are going to have. So to complete this, this is what is going to happen. To complete that, back to the question. Obviously, when y is 0, t is 0. When y is infinity, t is also infinity. So I have integral from 0 to infinity of y squared. Y is this. Y is all this. Y squared will be t over 2 raised to the power of 2 over 3. Then I have e raised to power minus t, because 2y raised to power 3 is t. E raised to power of minus 3. The y is 2 raised to power minus 1 over 3 t raised to the power of minus 2 over 3 dt. That's what we are going to have. So that at the end of the day, let all the constants come outside. This one will be 1 over 2 raised to power 2 over 3. This is 3 raised to power 2 over 3, 2 raised to power 2 over 3. So 1 over 2 raised to power 2 over 3. All these ones two are constant. Let them come outside. Multiply by 2 raised to the power of minus 1 over 3 integral from 0 to infinity. This one will now be t raised to power 2 over 3 multiplied by t raised to power minus 2 over 3, then e raised to power minus 3 dt. So to complete this one can also be written as 2 raised to power minus 2 over 3 multiplied by 2 raised to power minus 1 over 3, everything over 3, integral from 0 to infinity. By the time you do law of indices here, you will see that this one will actually become 2 raised to power 0, because dt 2 over 3 minus 2 over 3, that is 2 over 3 minus 2 over 3 will give me 0. So I have 2 raised to the power of 0, e raised to power minus t dt. This one will become 2 raised to the power of minus 1. It's also law of indices 2, 2. So this one will now be minus 2 over 3 minus 1 over 3, which is minus 3 over 3, which will give me minus 1 over 3. This integral from 0 to infinity, t raised to power 0, e raised to power minus 3. This is 3 raised to power 0, so that means that is gamma of 1, gamma of 0 plus 1, which is gamma of 1. This 2 raised to power minus 1 is 1 over 2, multiplied by 1 over 3, that will give me 1 over 6, multiplied by gamma of 1 is 1, so 1 over 6 times 1 over 6, so the answer to the third one is 1 over 6. The fourth one, number 4. Number 4 question, it says integral from 0 to 1 of s ln s raised to power 3 ds. Integral from 0 to 1 of s ln s raised to power 3 ds. So in this case, look at what I will do. I want to make it in terms of the gamma function. Gamma function has e raised to power minus t. E raised to power minus t. So this ln s is what is the only thing that can give me e raised to power minus or e raised to power in this expression. So if I let t, look at it, if I let t to be equal to ln s, then s will be equal to e raised to power t. But I want e raised to power minus t, so I know what I will do. You just let t to be equal to minus ln s. And what does that mean? It means that s will be e raised to power minus t. If you bring this minus here, that's minus t equal ln s. S will now be e raised to power minus t. So now, all ln s will be equal to minus t. That's what we have. So differentiate ds is equal to, when you differentiate, ds will be equal to minus e raised to power minus t dt. Now, in this case, when s is 0, what is t? When s is 0, look at it when s is 0. You know, we have to change the boundary as well. We have to change the bound of the integral. When s is 0, that means t will be equal to minus ln 0. Ln 0 is minus infinity. How do I know? Because e raised to power minus infinity gives 0. You know that e raised to power minus infinity gives 0. Taking the ln of both sides, that means ln of e raised to power minus infinity is equal to ln of 0. Ln of exponential will give me what is at the power. Minus infinity is ln 0. So that ln 0 is minus infinity. So I have minus multiplied by minus infinity, I have plus infinity. So when s is 0, t is infinity. And when s is 1, what happened? T is equal to minus ln 1. Ln of 1 is 0. Ln 1 is 0, it's obvious. Minus 0 is still 0. 0 plus 1 is sign in particular. So when s is 1, t is 0. So at the end of the day, this is what we are going to resolve into. This is what we are going to resolve into at the end of the day. So I will have substituting this value. So let me write the question so that you can see. Integral from 0 to 1 of s ln x raised to power 3 ds is equal to integral. When s is 0, t is infinity. I have infinity here. When s is 1, I have 0. So I have infinity at the denominator. I have 0 at the numerator. So I now open a bracket. What is s? S is equal to e raised to power minus t. Put it there. E raised to power of minus t multiplied by ln s. This is ln s. Ln s is minus t. Minus t. ds. ds is minus e raised to power minus t dt. Minus. Multiply. That's another multiplication. Multiply by e minus e raised to power minus t. Everything dt. Of course, minus times minus raised to power 3 is here. Raised to power is all raised to power 3. So raised to power 3 should be here. So at the end of the day, I will have integral from this. Let me still write it this way: 0 to infinity of, if I open this bracket, this one will give me minus t raised to power 3 e raised to power minus 3t multiplied by another minus e raised to power minus t dt. Minus times minus will give me plus, so I will have an integral from infinity to 0 of t raised to power 3 e raised to power minus 4t dt. E raised to power minus 3t multiplied by e raised to power minus t gives me e raised to power minus 4t. So I will swap this bound. And in integration, when you are dealing with integrals and you want to swap the ground, that I want to put this infinity up and bring this 0 down. Just introduce a negative sign, that's all. So this one will become minus is 0 to infinity of t raised to power 3 e raised to power minus 4t dt. So again, maybe I will say let u be equal to 4t. So the t will be equal to u over 4. So that the t will be equal to 1 over 4 du. You understand what I'm doing? So that at the end of the day, when t is 0, u will be 0. When t is infinity, u will also be infinity. I will have minus integral from 0 to infinity. This is t. T is what? U over 4. That is u over 4 raised to power 3 multiplied by e raised to power minus 40. 40 is u. That is e raised to power minus u multiplied by the t. The t is 1 over 4 du. 1 over 4 du. So that I will have minus integral from 0 to infinity of 1 over 4 raised to power 4 du raised to power 3 e raised to the power of minus u du. So 4 this is 4 raised to power 3 multiplied by another 1 over 4. That's why I have 1 over 4 raised to power 4 u raised to power 3 e raised to power minus u du. Bring the constant out. This one will give me minus 1 over 4 raised to power 4 integral from 0 to infinity of u raised to power 3 e raised to power minus u du, which is exactly gamma function. 1 over 4 raised to power 4 is 256. That is 1 over 256 gamma of 4. Gamma of 4. You know why it is gamma of 4? This is u raised to power 3. 3 plus 1 will give me 4. So that is gamma of 4. And gamma of 4 is 3 factorial. To complete that question, gamma of 4 is 1 over 256 multiplied by 6, because gamma of 4 is 3 factorial. 3 factorial is 6. So this one will give me minus is missing. There is a minus sign here. So that will give me minus 3 over 128. 2 can go. Minus 3 over 128. Then the last one, number 5, the 5th question. Integrate from 0 to 1 of s raised to power 4 log of 1 over s integral of raised to power 3 dx. Just the way we solve this, we will also solve this one like that. This log you are seeing here is exactly lean. Log, when you see log like this, it means log to base e, and log to base e is lean. So that's what we are going to do. In this case, we don't need to put any negative sign in front of this. You just say let t be equal to this one, log of 1 over s. Don't forget, from law of logarithm, 1 over s is s raised to power minus 1. So this is log of s raised to power minus 1. And this exactly will be minus log of s. So that means that t is minus log of s. So make s the subject. By the time you make s the subject of formula, s will be equal to e raised to power minus t. That's what you are going to have. Differentiate now. ds is equal to minus e raised to power minus t dt. Don't forget again, when s is 0, let me write it. When s is 0, what is t? T will be negative log of 0. I've solved it before. Ln of 0 is minus infinity. Minus times minus will now be plus, so that means t will be infinity. When s is 1, I have t to be minus ln or minus log 1. Log 1 is 0, so this one will be 0. So that at the end of the day, this one will become integral from infinity to 0. because when it's 0 is infinity, when it's 1 is 0. From infinity to 0, x raised to power 4. This is it. I have e raised to power minus d raised to power 4 multiplied by this one. Don't forget, t is log of 1 over x. That means t, everything here is t raised to power 3. T raised to power 3. So you can check it. Log of 1 over x, everything in this bracket has been replaced with t. So this is t raised to power 3 ds. ds is what? Multiplied by negative e raised to power minus d dt. That's what we are going to have. So we will now have this negative. If I remove this negative, I can swap this integral. No, to swap the integral, you introduce a negative. And the negative times this negative will give me positive number, 0 to infinity. So this negative will have multiplied the negative I would have introduced when I swap this integral. So this one will remain e raised to power minus 4t multiplied by t raised to power 3 multiplied by e raised to power minus t. Don't forget, I told you I have swapped this bound, that is, it's now from 0 to infinity, and when you do that, you will introduce a negative sign. That negative sign multiplied by this negative I have brought it outside too. Negative times negative will give me positive. That's why you can't see any negative value here again. So dt. So we still solve. So we still solve now. This is the next thing that will happen. We are here, integral from 0 to infinity. T raised to power 3, e raised to power minus 5t, e raised to power 3 raised to power 3, e raised to power minus 5t dt. Again, this is not raised to power t only. So let u is be equal to 5t. So t will be equal to u over 5. dt will be 1 over 5 du. When t is 0, u is 0. When t is infinity, u will also be infinity. So our 0 to infinity of t raised to power 3, t is u over 5. U over 5 raised to power 3 multiplied by 2 over 5 raised to power 3 multiplied by e raised to power minus u dt. dt is multiplied by 1 over 5 du. This is 5 raised to power 3. 1 over 5 raised to power 3 multiplied by 1 over 5. That will give me 1 over 5 raised to power 4. Integral from 0 to infinity of u raised to power 3, u raised to power 3, e raised to power minus u du. So that at the end of the day, we eventually have a gamma function now. This is 1 over 625 gamma of 3 plus 1. I hope you understand what this is. Gamma of 3 plus 1. So 1 over 625 gamma of 4. Gamma of 4 is 3 factorial. 3 factorial is 6. So the answer will be 6 over 625. So that's all for this first lecture. The second lecture will continue from here where we stop. Please, I would like you to encourage me by subscribing to this YouTube channel and liking this video. Thank you.